Today we are going to discuss about two relations, that is x modulo y and x congruence to z modulo y. First of all, we will discuss this one, x modulo y. Now x modulo y means the number x modulo y is the remainder when x is divided by y and is pronounced as x modulo y. Therefore, if 7 modulo 3 we are saying, that means its value will be 1 because 7 is 2 3 are 6 plus 1, remainder is 1. So when 7 is divided by 3, it is giving a remainder as 1. So this is the meaning of 7 modulo 3. Now come to the z congruence to x modulo y. So what does it mean? The number z congruence to x modulo y means z and x have the same remainder when divided by y, or z minus x have same remainder 0 on division with y. So for example, 7 and 25 congruence with modulo 3 means 3 to the 6 plus 1 and 3 8 is 24 plus 1. So same remainder 1. Here one another example, 11 congruence to 14 modulo 3. Here 3 3 is 9 plus 2 remainder for 11 and 3 4s are 12 plus 2 remainder for 14. So both are 11 is congruent to 14 with modulo 3, leaving the same remainder 2. 7 is congruent to 25 with modulo 3, leaving the remainder 1. Also, in other words, z minus x have the remainder 0, means 7 minus 25. 7 minus 25 is minus 18. Minus 18, 3 6 are, so leaves the remainder 0. Similarly, 11 and 14 are congruent modulo 3, so 11 minus 14, that is minus 3. Again divisible by 3, leaving remainder 0. So either z minus x will give you remainder 0, or both will give the z and x both will give the same remainder when divided by y. This is the meaning of z congruence to x modulo y. Now let us discuss important properties related to this congruence modulo. The notation x congruence to y modulo 3 means x and y leaves the same remainder when divided by 3, either 0 or 1 or 2, because 3, in case of division by 3, it will give remainder as 0 or 1 or 2. So 3 divides x minus y, in other words, and leaves the same remainder 0. Okay, when we will subtract these two, then it will give the remainder 0 on division by 3. These are the two definitions for the x congruence modulo y 3. Now it is not a function, it is a binary relation, means it is only related to two numbers in relation. It defines an equivalence relation because this relation is reflexive, symmetric and transitive. We will prove further. And also it partitions them into 3 disjoint sets, means your integer will be divided in 3 disjoint sets like 0, 3, 6, 9, 1 set. One will be 1, 4, 7, 10, where remainder will be 1. 1 will be 2, 5, 8, 8, 11 and so on. 11 plus 3, 14 and so on. Remainder will be 2. So these 3 sets will be there for the congruence modulo 3 in case of integers. Now 5 congruence to 2 with modulo 3 means 5 minus 2, that is 3. 3 is divisible by 3, leaving remainder as 0. So this is the meaning of congruence modulo. Now we will prove that this congruence modulo relation x congruence to y modulo m is an equivalence relation. So let us see, x congruence to y modulo m means m divides x minus y. Okay, now x minus x is 0, so 0 is divisible by m. So we can say that x congruence to x modulo m means with respect to division m, x minus x is divisible by m. So this is reflexive relation with itself in relation. Now symmetricity, x is congruence to y modulo m means x minus y is divisible by m with some number km. So take minus common. So minus x plus y is divisible by km. So y minus x is divisible by minus km. So we can say that y is also congruent to x with modulo m. So this is symmetric relation. X, y and yx both are with respect to modulo m same. So symmetric relation. Now transitive relation, x is congruent to y modulo m and y is congruent to z modulo m, means m divides x minus y and m divides y minus z. So m divides x minus y plus y minus 8 together. And in this case, we can say that m dividing x minus 8 because y cancelled. So x is in congruence to z and modulo m. So transitive relation is also following. So in this way, we can say that this relation Rxy belonging to integers such that x is congruence to y modulo m is an equivalence relation. Thank you.